Now in your syllabus, you also need to know which quantities are vectors, which quantities are scalars. So what's the definition of a scalar quantity? A quantity that only has
magnitude
and no direction, right? Not.
Yeah.
Whereas vectors will be
Both magnitude and direction.
both magnitude and direction. Okay. So which quantities are vectors, which quantities are scalars is actually when we go through the topic one by one, each of the quantity I will tell you lah. Okay. But you cannot use some shortcut one because some people say what if I take a vector times a vector, do I get a vector? Vector times scalar get a scalar, scalar times scalar gets a scalar. There's no such formula like this, alright? So your only way is to know during the topic I'll tell you whether it's direction or not. And if in the exam you can figure out a particular direction, that means during calculation we did mention how to find the direction, that means it's vector. But if we never talk about how to find the direction, that means it's scalar. For example, when you calculate work done and energy, do we ever talk about direction of work done or direction of CAIE or direction of GPE? Do we talk about direction? No, that means it's scalar. Alright, but if I mention about displacement, velocity to the left, to the right, acceleration, up, down, so that means there will be a direction, so it's vector. Okay, now you cannot have that formula which I told you like vector times vector is no such thing. For example, right, like work done is force times displacement, so it's vector times vector, but yet your work done is a scalar, so you can't say that. And for moment, then it is force times perpendicular distance, so it's actually vector times a scalar, but your moment is a vector. So you see now, so you cannot use any of this shortcut to find out. Alright, okay, so the next thing we'll talk about is how to solve quantities, vector quantities when you add them or subtract them. So we talk about addition and subtraction of vectors. Now, because vectors have a direction, right? So we have to consider direction now when we want to add or subtract. If they are scalars, right? For example, if your mass is 50 kg, my mass is 60 kg, then our total mass is 110. So no matter where you go, you can go to UK or Australia, it doesn't matter. Our total mass is the same because it doesn't have to depend on direction. But when you talk about vectors, then direction is super important, right? Because for example, let's say you have a vector F1, which is equals to 5 newtons to the right, then another vector F2, which is 3 newtons to the right also. So then if I say F1 plus F2, so it means that the total will be 8 newtons. So if they are same direction, we just add them up together. But you see what will happen is, let's say my F1 is still 5 newtons to the right, but let's say my F2 is now 3 newtons to the left. If I still write F1 plus F2, I cannot add anymore because they are opposite directions. So when they're opposite direction, I will end up subtracting, so I get 2 newtons, even though I write F1 plus F2. So why? Because even though this both F1 plus F2, but because direction is the same, direction is opposite, so the way we solve is different. So direction is important. So these two are still relatively easy. That means vectors which are parallel, this means parallel like this, are easy. Same direction you add, opposite direction you minus. So the complication starts when the vectors are not parallel to each other. For example, let's say you have one vector, 4 newtons, let's say F1, 4 newtons to the right, and then you have a vector 3 newtons, which is, let's say, F2 upwards. So when I say F1 plus F2, I cannot just take 4 plus 3 or 4 minus 3 because they're not parallel. So whenever they're not parallel, one of the best ways to solve it is to draw a vector diagram. So a vector diagram is not same as a free body diagram. A free body diagram means you draw the body with all the forces acting on it. So you just label all the forces, you're fine. But a vector diagram has a specific way of drawing, and if you don't follow it, you'll get a wrong answer. So when I say F1 plus F2, that means I'm adding F1 to F2 lah. So I will first draw F1. So let's say I draw F1, 4 newtons here. Alright, so I want to add F2 now. So where should I draw my F2? Some people ask me, can I draw here or here? Does it make a difference? It does. In a vector diagram, when we say F1 plus F2, then we must start drawing F2 from where your first vector ends, which is here. You cannot draw from here. So if the vector moves from here to here, this is where it stops. So this is where you draw the F2. So you must draw from here. So which is 3 newtons. So what you're basically saying is, if I walk from here to here and then walk from here to here. What is my resultant? So my resultant is the same as walking from here to here. So basically you're drawing a line that joins the beginning to the end. So this was the first vector I drew starting from here. This is the second vector I ended. So you draw from beginning to end. You put a double arrow. That is your resultant. And you can use Pythagoras to solve. You get 5 newtons. So that means your resultant is 5 newtons. Now this applies for any type of vectors, whichever direction. That means it doesn't have to be perpendicular. For example, let's say you have one vector here. F1 is 5 newtons. And then another vector here, F2, is 3 newtons. But this vector, it has an angle of 30 degrees to the horizontal. So if I want to find F1 plus F2, so what I can do is I can do the same way. I draw one of the vectors first, which is F1 now. Now, some people ask me, can I draw F2 first? Can, because F1 plus F2, is it the same as F2 plus F1?
Yes.
Can, so you can actually draw either one. So, but in this case, I choose to draw the first one first because it's easier. Horizontal is easier. So where should I draw my second vector?
Here.
The beginning or the end?
Beginning.
The end. You must always start drawing the second vector from where the first vector stops. Understand that? So you must start drawing from here. Now, if you draw from here, you'll get a different answer. I'll show you now. Let's say I look at the correct. Let's say I look at the correct one first. Let's say I don't want. Let me say I use these two lah. So my resultant would be here, right?
Yeah.
Now imagine if I had drawn this and this. So my second vector is this, right? So when I join, how do I join? I join like this. So is this resultant the same as the first answer? No, it's not. So you say, that's why I say, if you don't follow the vector diagram, the rules, then you'll get a completely different answer. Okay, so you must follow that rule. Okay, so you can do the same way. But some people say, how do we determine the length, right? So there are 3 ways actually. You can either draw to scale, or you can sketch it and calculate, or you can actually resolve. So I'll show you how we do all 3 methods now. So let's talk about how to draw to scale. Now you can use a ruler and a protractor to draw to scale. So what you will first do is you got to set your scale. Let's say you say 1 centimeter is to 1 newtons. Then you take out your ruler, alright, and you draw 5 centimeters, and then you label it as 5 newtons. Then you take out a protractor, then you make sure that this angle here is 30 degrees first. Okay, that means you put a protractor, maybe it looks like this. So this is a protractor. Alright, so you make sure that this is 30 degrees. And then you draw a line 3 centimeters long. Okay, 3 centimeters long and label it as 3 newtons. Then you join from beginning to end. Alright, double arrow, and then use a ruler to measure this length, and that will be your resultant. You don't have to calculate anything. So just by taking a ruler and measuring how many centimeter, which is how many newton, you get a force. And if you want the direction, usually we will state the direction of the resultant force using either the horizontal or the vertical as a reference. That means, what is this angle from the horizontal, or what is the angle from the vertical? Like for example, if you want to take the angle from here to here, you take a protractor and you measure it. Alright, so you take the angle from the horizontal. Okay? Now, if you want to sketch only, you don't want to draw to scale, also can. So what you will do is, now if you're sketching, you don't have to draw to scale. That means you can do what I did here, because in this diagram I didn't use a ruler, I didn't use a protractor, right? I said you imagine only lah. But let's say you just sketch like me. You can also calculate this without drawing to scale. So how do you draw? You still need to follow the same rules. That means you draw the first vector, from where the first vector stops, you draw the second vector. But then you estimate this length, you estimate this length, you estimate the angle. You're not actually measuring to scale. Then you just draw this, right? So when you calculate, you can use the cosine or the sine rule. If you're using the cosine rule, then the FR squared will be equals to 3 squared plus 5 squared minus 2 times 3 times 5 times cos. Now this is 150 degrees. So times cos, 150. And then you will get your FR. So this is one technique. Another technique to get the angle is to use the sine rule. So how to use the sine rule? Now imagine I recalculated my FR. So the sine rule would say, alright, on top here, so FR over sine 150 must be equals to 3 over sine theta, and then I will get the angle. Okay, so this is the second method. So I can get the resultant force and the angle as well, but purely by calculation, no measuring the scale. Okay. Alright, in the third method, we totally will not need to draw a vector triangle. But what we are going to do is we're going to use a technique called resolution. Now, what is resolution now? The idea is like this. Any vector can be resolved into two mutually perpendicular components. What it means is this. Now, let's say I have a vector here, F. This is my vector, so I want to draw the components for this. So what do you mean by components for this? That means how do I draw two different vectors that will add up to give me this? That is what I mean by components. But these two vectors which I draw to add up to give me this F must be perpendicular to each other. And usually one of the common ways of resolving is resolving horizontally and vertically, because horizontal and vertical directions are perpendicular to each other. So let's say I will do this and this. This is my component. That means I will draw the arrow like this. So what I'm trying to say is, if I walk from here to here and then here to here, it's the same as walking from here to here. So it means this vector can be represented by the two components. It's like this vector can be split into these two. That means instead of drawing this, I can draw these two. So this two is the same as this. That's called the component. So this horizontal component, let's call it Fx. And this vertical component, I call it Fy. And this angle, let's call it theta. So what is the Fx, the expression for Fx in terms of F and theta? What is the expression for Fy in terms of F and theta? We can actually use cos and sine. For example, remember that sine theta is equals to opposite over hypotenuse, right?
Yeah.
So therefore you get Fy equals to F sine theta. And if you're doing cos theta, so you will be cos theta is adjacent over hypotenuse. So the Fx will be F cos theta. So now, so I can label this as F cos theta and F sine theta. But some people ask me, is it therefore always that horizontal components are always cos and vertical is always sine? I say it's not necessary. It must depend on the angle. For example, if I drew this way as the components, if I drew the components this plus this, also can, right? So this Fy plus this Fx will give me my resultant also, right? F. So but let's say I give this angle, so use a different color. Let's say I use this angle as alpha. Then your expression will be slightly different. So the expression will be cos alpha will be adjacent, which is Fy over F, and sine alpha will be opposite, which is Fx over F. So I will end up with having Fy here as as F cos alpha. Can you see that? And my Fx I will end up as F sine alpha. So you will notice that sometimes your Fy is sine, cos, can be sine or cos, Fx can be cos or sine as well. So is there a shortcut instead of doing all this all the time? I say there's a shortcut. So the shortcut is like this. If I have this resultant and I have these two components, the component that shares the angle with my resultant will always be cos. The component which is opposite to the angle will be sine. So if you do this side, this component is sharing the angle alpha with my resultant, so Fy will be cos. But Fx is opposite to the angle alpha, so therefore Fx is sine alpha, F sine alpha. So that's a shortcut, you must remember. So what do we do with all this resolution? That means what we are trying to say in this method is, because these two vectors are not parallel to each other, But I can resolve this vector and this vector into their horizontal and vertical components. Then the horizontal component of this and the horizontal component of this can either add or subtract because they'll be parallel. And then the vertical component of this and the vertical component of this can also add or subtract because they will also be parallel. Then you will get the total horizontal, then you get the total vertical, and then we will draw a Pythagoras to find the resultant. Alright, so I'll show you how. So now let's say you want to do this, right? So let's resolve. So we're going to find the total horizontal vector first. I'm going to add up the horizontal for this and the horizontal for this. So you need to set a sign convention. So let's say I step to the right as positive. But if you don't set, then you get confused later whether your answer is right or left. Because when you get a positive or negative value and you have a sign convention, then it's clear whether you took right or left. Your total is right or left. So like for example, the horizontal component for F1, you don't have to resolve because it's already horizontal. There's nothing to resolve here. So it's to the right, so we'll just write as positive 5. If it was to the left, you write as negative 5. It follows our sign convention here.
Okay.
Then what about this F2? How do I resolve this? So imagine you resolve it to two components. That means it moves this way and then this way. So the horizontal component here, it is sharing the angle with my resultant. So it is cos or sine?
Cos.
Cos. So therefore, this will be 3 cos 30. And can you see this arrow is going to the right? So how do I know it's to the right? Because if I want to walk from here to here, I must walk to the right, then I move up. I cannot walk to the left, right? So I must walk right. And so that means this horizontal component is to the right and it's equivalent to 3 cos 30. So then you just put plus 3 cos 30. And then what about the vertical components? Okay, then we solve and then we resolve vertically. So I set upwards as possible. Always set the sign convention. So Fy, which is my total vertical vectors, total vertical components. Now, does this have a vertical component since it's purely horizontal? No. So therefore, it doesn't have. What about for this one? What is the vertical component? It is opposite to the angle. So therefore, it will be sine. So it will be 3 sine 30. And it's upwards, right? So it is positive 3 sine 30. So what you can do is you calculate this and this. So here you will get the answer as 7.6, okay, and the bottom one 3 sine 30 will be 1.5. So what you can do is you can actually 7.6 1.5. That means you have 7.6 to the right, 1.5 upwards. So this is the resultant. So you use Pythagoras to calculate, and then you can get the answer as 7.74. So that is your result. So this is another way of calculating. And if you want to find the angle, you can also just label this as theta, because always you need to find the angle of the vector, because vector consists of magnitude and direction. So you also need the direction. So what's the direction? You can use tangent theta equals to 1.5 over 7.74. Then you can get your theta. So this method, you don't have to draw a vector triangle, except at the end when you want to add the horizontal and vertical. But you don't have to use these two to draw a vector triangle. Okay?
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.